So it's a little bit blurry, but I just took pictures of the pre-test and put them on here. So I'll go through and I'll try to work this out, show you what to do on these. So on this first one, it says write the first 5 terms of the sequence, meaning you're supposed to find A1, A2, A3, and I'm going to run out of room, A4, and A5. So what that means is you're going to replace n each time with 1, 2, 3, 4, and 5. So on A1, it's going to be negative 1 to the 1 power, 3 to the 1 power minus 1 over 3 to the 1 power plus 1. A2 is going to be negative 1 to the second power, so I've replaced that n with 2, that n with 2, and that n with 2. So 3 squared minus 1 over 3 squared plus 1. A3 is going to be negative 1 to the third power, 3 cubed minus 1, 3 cubed plus 1. A4 is going to be negative 1 to the fourth power, 3 to the fourth minus 1, 3 to the fourth plus 1. And A5 is going to be negative 1 to the fifth power, 3 to the fifth minus 1, 3 to the fifth plus 1. So if I look at A1, negative 1 to the 1 power, so basically negative 1 to any odd power is going to be negative. Negative 1 to an even power will be positive. So this term is going to be negative. So 3 to the 1 power is 3 minus 1 is 2. 3 to the 1 power is 3 plus 1 is 4, so that reduces to be negative 1/2. A2, 3 squared is 9, minus 1 is 8. 3 squared is 9 plus 1 is 10, that reduces to be 4/5. 4/5. A3, 3 cubed is 27, minus 1 is 26. And then 27 plus 1 is 28, that reduces to be 13/14. And the negative is there because it's to an odd power. Okay. A4, 3 to the fourth is 81, minus 1 is 80, so that's 80 over 82, so that's 40/41. And then to the fifth is 243, minus 1 is 242, plus 1 is 244. That's a negative to an odd power, so it's negative. So that's negative, and this reduces to be 121 over 122. So that's how you do the first question. This next one, this is my first term, second, third, fourth, fifth. So we're trying to find any pattern on here. It's kind of hard to tell right there, but if I take out 2, if I divide all of these by 2, I have 1, 2, 4, 8, 16, and I go, oh, that's just multiplying by 2 each time. So if you wanted to, you could even leave it as it is. So sometimes it's easier to do that. Sometimes it's just as obvious to say 2 times 2 is 4, times 2 more is 8, times 2 more is 16. So you really see that we're just taking 2 to the power. Like this is 2 to the 1 power, 2 squared, 2 cubed, 2 to the fourth. So if I do that and I just go 2 to the n power, that would generate 2, 4, 8, 16, 32, but it doesn't generate a negative. But now if I put a negative in here, negative 2 to the n power, so when it's 1, that's negative 2. When it's squared, that's positive 4. Cubed makes it negative again, so there it is. That generates my sequence, and we're done. On this one, you can type this in your calculator. You can go 25, math, probability, the fourth one, divided by 21, math, probability, the fourth one. And I probably ought to put those in parentheses just to make sure it does it right. And it gives me 303,600. So this is 303,600. The other way is to realize all the 20, so this is 25 times 24 times 23 times 22 times 21 and so forth. And on the bottom it's 21 on down. So all those cancel off and you just have 25 times 24 times 23 times 22. So that's one way to do that one. This next one, I'll show you the fastest way, and then I'll show you the long way. The fastest way is to realize on your calculator there's a button. So if I go math and go all the way down to the bottom, it says summation. And it brings up this thing, and it has little spaces for things. You can use K, you can use whatever variable you want, or you can just use X. So on my problem it says X equals 1, and then it goes up to 8, so I put an 8 up there. And then in here it says it's X squared plus 1, so I go X squared plus 1. So I just type that in my calculator just like that, and I hit enter, and it tells me that the value is 212, and I'm done. The long way is to plug in 1 for K, plug in 2 for K, plug in 3 for K, 4 in for K, 5 in for K, 6 in for K, 7 in for K, and 8 in for K. So 1 squared is 1, plus 1 is 2. 2 squared is 4, plus 1 is 5. 3 squared is 9, plus 1 is 10. 4 squared is 16, plus 1 is 17. 5 squared is 25, plus 1 is 26. 6 squared is 36, plus 1 is 37. 7 squared is 49, plus 1 is 50. 8 squared is 64, plus 1, which is 65. Now that you have all of those, you just add them all together. So 7 plus 10 is 17, plus another 17 is 34. 34 plus 26 is 50, plus another 50 is 100. Plus 37 is 137, plus 65 is 12, 1, 4, 6, 0. Somewhere I messed up on one of my numbers. So 7, 17, 34, well, that's 60. So 110, 147. So that's 212. Okay, so that's the other way you can do it. Either way is fine. On this one, again, I'm going to try to see if I can see a pattern by dividing these by 2 first. So I get 1, 4, 9, 16, 49. This is my first term, this is my second term, this is my third term, fourth term, so forth on out. Well, if I look at this, 2, 3, 4, how could I get, using this, how could I get 16? How could I get 9 from 3? Oh, I see it's just a squared. Really, it's just n squared. So this is 1 squared, 2 squared, 3 squared, 4 squared. So that must be 7 squared. Gives me 49. So now summation. So we write our little summation guy. We start at 1. So n equals 1. We go up to 7. And my formula is n squared. And that's all that it is. All right, so now on the next problem, on number 6, it says determine if they're arithmetic, geometric, or neither. If they're arithmetic, find the common difference. If they're geometric, find the common ratio. If neither, write neither. So I look at the first one, 1, 3, 9, 27. Oh, I'm just multiplying by 3 each time, so it's geometric. And I'm multiplying by 3, so r is 3. I look at this one, and the bottom is exactly the same as what it was on number 6, 1, 3, 9, 27. So again, I'm multiplying by 3, but it's on the denominator. So that goes on the bottom. That stays as a 3. And the other thing I notice is the signs are alternating, positive, negative, positive, negative. So I must be multiplying by a negative 1/3 each time. So again, that's geometric, multiplying by a negative 1/3. So now in this one, 3 times 3 is 9, times 3 more, oh, that's not multiplying. 3 plus 6 is 9, plus 6 more is 15, plus 6 more is 21. Oh, so I'm adding each time. I'm adding by 6. So that's arithmetic. This one, 6.4 to 5.6. If I'm minus 0.8, oh, it looks like it does that every time. So I'm minusing 0.8. So my difference is a negative 0.8. So that means, again, it is arithmetic. Now the next one, number 10, says it's arithmetic, which means I add or subtract by the same amount each time. So it tells me A6 is 28, A14 is 16. So I'm going to find the difference by going 16 minus 28. So that tells me I went down by 12. From 28 to get to 16, I went down by 12. How many terms was it? Well, so from 6 to 14, 14 minus 6 is 8. If I reduce that, it's negative 1.5. So that tells me I'm going down each term by 1.5. Now it says write the first 5 terms. So if I'm going down 1.5 each time, that means A5 has to be bigger than 28, because remember these are going down. So A5 is 29.5. So all I'm doing is adding 0.5 onto the term to get to the next one. So A4, if I add 1.5 to that, takes me to 31. A3, if I add 1.5 to that, takes me to 32.5. A2, if I add 1.5 to that, takes me to 34. And A1, if I add 1.5 to that, takes me to 35.5. Now number 11, it says arithmetic sequence, find the formula. So I know AN equals DN plus C. C equals A1 minus D. So it tells me my first term is 15. Minus a minus 3 makes that a plus. So it says C is 18. So what I have then, the difference is negative 3, and plus 18 is my formula. Okay, and if I plugged in 1, I would get 15. So that formula works. I can check it. So I've already done number 11. So now let's look at number 12. Find the indicated nth partial sum of the arithmetic sequence. This 12 means we're going out to 12 terms. So here's my first, second, third, fourth, fifth. You can keep counting if you want. 12, that would be my sixth term. Add 4 more is 16. That's my seventh term. 20, that's my eighth term. 24 is my next term. 28, that's 10. 32 is 11. 36 is 12. There's my 12th term. So now I could just use this SN sum formula equals n divided by 2, A1 plus AN. So in this case, n is 12, so that's 12 divided by 2. My first term is negative 8. My last term is 36. Or you could just add all these together, 36 plus 32 plus 28 plus 24 plus 20 plus 16. Anyways, type those in your calculator and you get the same answer. So 6 times 38, 6 minus 8 is 28. So 6 times 28 is 168. Okay. The other way is to write this in this form. So n equals 1. I go up to 12. So this is arithmetic. AN equals DN plus C. So C is this term in front, so that's negative 12. My difference is I'm going up by 4 each time. So this is my formula that I could put right here, 4n minus 12. So now I can just go to my calculator, hit math, go up to that summation, x 1, 12. Now I write in my formula, which was 4x minus 12. I come out of it and I hit enter. And it tells me it's 168. So 168. Again, on your calculator, you know, 6 times 28, it better give me 168. So it gives me the same thing. So just a different way to do it, 2 different ways to do it. Third way, you could add all of those together. You could add that 36, 32, 28, 24, 20, 16, 12, 8, 4, 0, negative 4, negative 8. So you could add those all together and get the same thing. Okay. Number 13 says write the first 5 terms. So A1 equals 1, R equals 3/4. So all we're doing each time, because it's geometric, means we're multiplying. Whoops, that's A2. We're multiplying by 3/4. So 3/4 times 1 is 3/4. Now I multiply by another 3/4. So I multiply the top by 3, which makes 9. Multiply the bottom by 4, that makes 16. A4, I multiply the top by 3, that's 27. A5, I multiply 27 by 3, and that's 81. So that's the numerator. The bottom, I'm multiplying it by 4. So 16 times 4 is 64. Multiply that by 4, and it's 256. So I have it wrong on my key because I put A1 on my key as 3/4, but really A1 is 1. They tell you that. A2 is 3/4. So on the answer key, realize that's wrong on the printed version. This is what it should be. Now it says find the indicated term of the geometric series, and we're supposed to find the fifth term. So remember the formula, AN equals A1 times R to the n minus 1. So A1 is 100, R is negative 1/10, n minus 1, so 5 minus 1 is 4. So this is a negative to an even power. It's going to come out positive. I'm going to have 100 over 10 to the fourth. 100 is 10 squared. So those two go away with two of those and leave me with 1 over 10 squared, which is 1 over 100. You could type it in your calculator. I just did it that way because I thought that might be faster for me. But just in case you were wondering, 100 times 1 divided by 10 to the fourth. Enter, math, enter, enter, 1/100. Okay, so that's that problem. Okay, so number 15 says find the sum of the following series if it exists. So n is 0, so to get the very first term is when I plug 0 in for n right here. Anything to the 0 power is 1, so 2 times 1 is 2. So that's the first term that we get from this. So I have that formula, S, not A. S sub n equals A1, 1 minus R to the n over 1 minus R. A1 is 2. 1 minus 2/3. Now I start at 0 and I go up to 20. If I start at 1 and I go up to 20, that's 20. But since I start at 0, we're adding 1 more into there. So there's actually 21. So I'm going to go 2/3 to the 21. All over 1 minus 2/3. And now I just type this into my calculator. So I go 2 times, and I'm actually going to put a parenthesis at the very beginning. So insert a parenthesis, 2 times 1 minus 2 divided by 3 to the 21 power. Close those parentheses, divided by 1 minus 2/3. Close those parentheses. It tells me it's 5.99879. The other way to do this is, again, hit math, go up, summation, put in x or n or whatever you want to, 0 up to 20. Inside of here, I have 2 times 2, whoops, not 22, 2 divided by 3, and that says to the nth power on that. So I'm just going to use the x because that's the variable I used instead of n. Then I hit enter. And it tells me the same thing as what I had before. So either way, you'll get the same answer. So that's approximately 5.999, almost 6. Okay. So that's number 15. Now on this one, because it has an infinity on it, we had a hard time typing it in the calculator. You'll get pretty much the same answer if you plug in a 99 at the top of this. Well, that's a horrible summation. If you plug in 99 on the top of the summation. So if you do it in your calculator and type in 99, you'll probably get the same answer. But here's the short way. If I plug 0 in for this n, I get 3. Anything to the 0 power is 1, so 3 times 1 is just 3. So my first term is 3. So the formula for this is A1 over 1 minus R. So 3 over 1 minus 1/4. 1 minus 1/4 is 3/4. Divide by a fraction is the same as multiplying by its reciprocal. The 3's cancel and you get 4. Okay, so that's how I would do that one. Number 17, you just type that right into your calculator. So I hit math, go over to probability, go down to the third one, or hit 3. I hit a 12. Move it over to the other box, hit 8, hit enter, 495. Okay, now on this one you're supposed to expand. So to do that you need Pascal's triangle. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1, 1, 6. Remember you're adding these two together. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6, and then 1. 1, 7, 21, 35, 35, 21, 7, 1. My power is 6, so really I need just this row. I didn't need to do that next one. So that's what I need. So I'm going to write those down. 1, 6, 15, 20, 15, 6, 1. So that's that row of Pascal's triangle. Now I come to this. I see that's a negative, so realize when I start putting my y's in here, they're going to just alternate the signs. So I'm just going to do that right now. Then I don't have to worry about that negative. So remember, this is y to the 1 power, so this is really going to be negative y to the 1. So that negative is going to be there. This is going to be negative y squared, so that's going to be positive, and so forth. So anyways, I just took care of my negative signs, so I don't have to worry about them now. So now this first one is 2x to the 6th. And then it's 2x to the 5th, 2x to the 4th, 2x to the 3rd, 2x squared, 2x to the 1 power. So that's my x's. Now my y's start going up. So y1, y squared, y cubed, y fourth, y sixth, fifth, plus y sixth. So now I have that. You can just type this into your calculator, 2 to the 6th. So 2 to the 6th is 64. So this is 64x to the 6th minus 6 times 2 to the 5th. So 6 times 2 to the 5th, 192. X to the 5th y. Plus 15 times 2 to the 4th. So that's 240. X to the 4th y squared. 20 times 2 cubed. 2 cubed is 8 times 20 is negative 160. 2 squared is 4 times 15 is 60. Two to the 1 is 2 times 6 is negative 12. And that's my answer. That's that binomial expansion. So now on this one it says to find the 4th term. So again, remember that the r is 1 less than this, so r equals 3. So we're going to have NCR, the first term, 2x to the n minus r times y to the r. So remember, these two add up to be 10. So we know r is 3, so we're going to have 10c3, 2x, r is 3, so 10 minus 3 is 7, y to the 3rd. So now what I do is I just go 10c3 on my calculator. So I hit math, move it over to probability, go down to the 3rd one, 10, put a 3 in here, enter, and I get that it's 120. So really it's 120 times 2 to the 7th. So times that to 2 to the 7th, I get 15,360. So 15,360, x to the 7th, y to the 3rd is that answer. Okay. The next one says find the 7th term, which means r equals 6. So I'm going to have 13c6, 3x squared to 13 minus 6 right here. So 13 minus 6 is 7. Negative 2y cubed to the 6th. So I'm just going to type this in the calculator. So math, probability, third one, 13 C6 times 3 to the 7th Whoops, that's still down there on the bottom. Times 3 to the 7th times negative 2 to the 6th. And I put that in parentheses so that I know I'm putting this negative 2 to the 6th power. Basically, all that does is make sure that comes out as positive. That would have been an odd power. It would have come out to be negative. Okay, and so then I get 240,185,088. So 240,185,088. So that takes care of the number. I now need to do the power on the variable. X squared to the 7th becomes x to the 14th. Y cubed to the 6th becomes y to the 18th. And that's my answer on this one. Hopefully you got the text. This needs to be changed from a 20 to a 35. So if it's not on your paper, make sure that's a 35. So I'm looking at here. It says, what is the coefficient of the term containing this? So I've got to do a little bit of work to figure out what term I'm after. But see how this is a y squared and that's x to the 5th? What did I do to squared to make it become an 8? Well, that has to be a 4. What did I do to 5 to make it become 35? Well, that has to be 7. Well, 7 plus 4 makes 11, so that matches things up. So remember, this is the r value. So I know I have NCR. Well, that's 11 for n. C4. 4x to the 5th is going to be to the 7th power. And negative 3y squared is going to be to the 4th power. So now it just wants the coefficient, because I know that it's going to be x to the 35th, y to the 8th, but it's just after the coefficient. So I can come back to my calculator, hit second enter. I don't know if this is going to be faster or not. So I'm back at the beginning. Make that 11C4. And then times 4 to the 5th. Nope, 7th. 4 to the 7th. So 4 to the 7th times negative 3 to the 4th. Hit enter, and it's 437,944,320. So that's 437,944,320. That's the coefficient in front of those variables. So that's what that one was after. (22) says find the sum of this. I'm going to go right to my calculator, hit math, go to the 0 one, x 3 8 2x, enter, and it's 66. You could do it other ways, and I show them on the paper, so if you want to see the other ways, you can look on the paper. Same thing on this one. You can just type that right into your calculator. Math, 0, x, 1, 36, 2 minus 5x. Hit enter. Negative 3258. And there it is. So again, on the paper, there's other ways to find this. So I show them to you on there. Okay. So negative 3258. On number 24, really the easiest thing that I did is realize it goes up by that each time. You can go through and make it a quadratic equation and use the quadratic formula and solve, or you can just come to your calculator and go, there's 1 time, there's 2 months, 3 months. You keep track of each time that you hit plus, 4 months, 5 months, 6 months. So this is the way I ended up doing it one time. So that was, you just have to keep track though. 1, 2, 3, 4, 5, 6. This next one's going to be 7. So, whoops. But you might even write on your little paper, this is 4, 5, 6, 110, 7, 120 is 8, until you just keep adding them together, and then when you get that answer, you're done. Or you could be like 50 plus 60 plus 70. You've got to get up there a ways. And so if you have them numbered on your paper, you can just type these in until you think you're getting close. So I'll stop at 200. I think I should be getting close. So there's 3,000. So plus 210, plus 220. Whoops, I did it again. 3,000 plus 210 plus 220. 3,430 plus 230 plus 240. That's 3,900, so that gets me close. So plus 250. So anyways, I don't know if I did it, all of those numbers right. I didn't check back on those, but that puts me above the 3,960. Okay. So, if you did it that way, said here's 1, 2, 3, 4, 5, 6, 7, and so forth, that would help you that way. Like I said, the other way I did it is I said, I know I have to get to here. I know this is my formula. It's 50 plus AN equals my first term. Let's see, DN plus C. So the difference is 10 each time. C would be the term before here, so that's 40. So I put that in here, 10N plus 40. I don't know what N is. In here, I know 50 plus 40 is 90, so I condensed those. So now I multiply that in. Half of 90 is 45, so that's 45N. N times N is N squared. Half of 10 is 5, so plus 5N squared equals 3,960. So then I get it equal to 0, so I have 5N squared plus 45N minus 3,960 equals 0. Plug that into the quadratic formula, negative B plus or minus B squared minus 4AC all over 2A. I think I actually divided everything by 5 when I was doing this on my own to make it work a little better. So then I just go to my calculator, negative 5 plus, oops, I need all that to be in parentheses because I'm going to divide it. So negative 5 plus the square root of 45 squared minus 4 times 5 times negative 3960. Get out of my square root, divide it by 2 times a, which was 5, and I get that it's 28. Which I think that's different than what it might have just messed up on here. It's supposed to be around 24. So I probably typed something wrong in right here. Oh, I did. I put negative 5. So there's 24. So if you do that, it gives you what the answer is. It says 24 times is n. When you do the negative version, it comes out to be a negative number, which doesn't make sense. So anyways, that's 24. Number 25, it's an infinite one with n equals 3, 6, 1/2, and minus 1. So if I plug 3 in here, 3 minus 1 makes 2. 1/2 squared is 1/4, so I have 6 times 1/4, which gives me 6/4, or 3/2, or 1.5. So now that I know it's an infinite one, I know that the formula is a1 over 1 minus r. So a1 is 1.5 over 1 minus 1/2. I have 1.5 divided by 0.5, which makes 3. On number 26, you just take 150,000 and multiply that by 110. And that'll tell you how much you're going to spend the first time. So that's part A. Part B, realize it's an infinite, keeps going on forever and ever, from x equals 1. It's going to be 0.7 is this x. And then the original amount that we start with was 16,500. So again, it's going to be a1 over 1 minus r. a1 is that 16,500, 16,500,000, sorry, over 1 minus 0.7. And you just type that in your calculator and it'll tell you what the answer is. So anyways, that's how you do that. So that's the pretest. Good luck with studying and getting